I once heard about ideal ratio between developers and testers is 3:1. That's 1 tester per 3 developers. I'm wondering what that number would be today, where there's an era of AI-generated code. But there's an interesting issue teams are facing today. AI is multiplying developers' output, and it's squeezing QA teams to test faster. On one hand, it would mean that more testers per developer. Why? Because one developers develop more code, so we need more testing power to keep up. On the other hand, tests can also be auto-generated, so we might need even fewer testers than before. So where's the truth? Let's divide this into 3 distinctive phases. First stage is prototyping. In that stage, AI already has proven something. It generated functional prototypes very quickly. They might not be perfect, they're often lacking production quality, but that's a great way to get alignment between development and validation, and test out our key assumptions. Next, there's a production phase, where new products are developed and tested. If we follow the classic method, we develop first, then we pass to testing. We quickly end up with a lot of bugs and delays. But because AI gets most of the basic coding right, typos and errors are much less frequent. The issues come from different places. They come from misalignment. This is not how we thought this should work. Too broad solution. The customer doesn't need that fancy 8 features. They just need those 2 basic ones. And inconsistency across components, integration issues, local optimizations versus global. The best method to handle those kind of issues are things like shift left. Build tests before coding, build documentation and requirements before tests, get the business cases right before all of that. That's obvious. It was the case even before AI, but it's far more important now. We can build the things faster than even before. The single source of truth becomes much more important than ever. AI cannot access our heads, not yet anyway, so we need to keep it in the shared space. Remote teams have surprisingly advantage here. They have documented such things by design, and that's how they succeeded. The next good practice was here for a long time, but it's more relevant than ever. Work on closed, well-defined chunks of work with clear inputs and outputs. These are easier to integrate, but more importantly, from QA perspective, they are testable. They offer natural integration points that can be tested and debugged. AI loves to generate comprehensive code. It's either all-in-one or generic to the extreme. Neither is good. So what's the good way to reduce testing load? Divide them into manageable chunks. The last thing in the production phase is this. Keep track of all the reasons why things evolve in the project. Why do you choose to implement things the way or another? Architecture design records are an effective way of handling that, this tribal knowledge and collecting SDLC-related data. That's essentially the understanding about relations between different elements of your project. Prototyping is usually very short in time frame. Production is much longer, and maintenance, the third phase, lasts the longest. The longer projects exist, the bigger it is, the balance between those 3 changes, and maintenance becomes the main one very quickly. Yes, mature projects have prototyping and production mix, but inevitably, all the software leaders I talk with say the same thing. I don't want AI to disturb a working system. That's the hidden truth of all the systems in production. We want them to be fancy, but more importantly, robust. So what's the implication of that for testing? The more mature system is, the more testing it needs versus development. In other words, once you have your system used by many, you want as few changes as possible and tested them as thoroughly as possible. What are the good ideas to achieve that? Smart selection of test scope. Yes, historical data is extremely valuable. Having data in place is only way to benefit from AI in that phase. Smart usage of QA resources in that phase is all about maximizing ROI. How much we can test in limited time and resources. The other best practice that always worked for me? Rigorous regression testing. Or maybe I should call it stage testing. CI/CD followed by regression testing, then broader feature testing, but all of them with clear time and scope boundaries. It always helped me maximize ROI, early detection of issues, and preventing breaking production. So far, I haven't mentioned AI a lot, but here's why. I think the underlying problems are still the same. How QA can keep up with faster code generation, how to use testing resources in most efficient way, how to make sure that we build the right things. AI amplifies them or can help solve them, but SDLC principles remain the same. So what are the 3 ways I think AI amplifies those problems? First, moving from prototyping to production without going back to a drawing board. It was always tempting to put prototype into production. A plausibly working AI-generated prototype is tempting, but it's shaky ground. Second, measuring speed by the amount of output. More code or more tests is never better. Generating just more codes and tests results in more maintenance costs. Those costs rise exponentially, and with bigger context, AI becomes less effective. Third, AI preference to output a lot of code versus making isolated changes. Refactoring is good as long as it doesn't break anything. And very often it unleashes hidden assumptions in the project, assumptions that cannot be easily resolved. Even if doable, cost of testing may outweigh the benefits. And what are the 3 ways AI can actually help? First, create multiple concurrent prototypes that can be tested out against the same set of tests to select the winning design. In the past, it usually required pre-selecting of prototypes or limiting the number of tests. Second, find hidden patterns in collected data. With well-documented context and historical test execution data, AI can reveal patterns and enable automated smart testing. The holy grail of regression testing, selecting minimal set of tests that perfectly test a code change. It's closer than ever. Third, helping to collect context and data. That was always a big issue to properly collect data in everyday engineering rush. AI creates a nice way to lower that burden, to collect knowledge about what we do and democratize tribal knowledge, making it accessible to everyone, including AI itself. So what are your thoughts on validation teams struggling to keep up with the growing output of coding? What area would you like me to dig deeper into? Let me know in the comments and see you in the next video.